Hello again, Algebra 2 standard students. I promised to make another video and I trust that this one will work well. The other one wasn't as good as I'd like it to be. So, let me go back and correct something that I got wrong on the previous one. And that was right here. If you just give me a few minutes to get set up, I thought I was, but I wasn't quite as set up as I'd like to be. So, I have to get my pen out and get everything in place. Thought I had it that way, but it wasn't. Okay, let's go back over this one. We're looking at, it says, for each of the following quadratic equations, find the following. A, axis of symmetry. So let's go ahead and do that first. It's going to be an x equal to line. So here it is. X is equal to negative b over 2a. So when we look, we find that b is the negative 4. So I'm going to write a is equal to 2. B is equal to negative 4. I think the last time I put 4, but it should be negative 4. And C is equal to 5. Okay? So here we go. Negative B, and B itself is negative 4, so it should be like that. Over 2a, 2 times a, which is 2. So minus negative would give me a what? Positive 4 over 2 times 2 is 4. So that's going to be 4 divided by 4 is 1. So this right here would be my axis of symmetry. X is equal to, saying negative again, I shouldn't say it. X is equal to 1. Okay? So that takes care of the axis of symmetry. Again, it's going to be negative b over 2a. That's all it is. And once you've identified your b and your b, sorry, negative 4, and your a, you can find it. Now, the vertex. Vertex is going to be more challenging to find. The vertex has 2 coordinates to it. It has an x coordinate, which I just found, and it has a y coordinate, which I will find. That's what we're going to find now. Okay, so using the x coordinate, we come to the equation and we plug in the x value into this equation, and that will give us the y value of the vertex. So f of x, you might remember, means y. So whenever I say f of 1, it's going to be the y value when x is 1. And that's what I want to find here. So here it goes. It's going to be 2 times, for x I'm putting in 1. That is squared. And then minus 4 times same one, which is x, and then plus 5. Okay, this was where my mistake was. So I got 1 squared, which is 1. 1 times 2 is 2. A negative 4 times positive 1 is a negative 4. And then plus 5. So when I simplify this, I have 2 minus 4 is negative 2. Negative 2 plus 5 is equal to 3. So this is the y coordinate of the vertex. So the complete vertex would be located where x is 1 and where y is 3. So that would be the address for the vertex. All right. The next one, I'm pleased to say, will be very simple. The y-intercept is just the c. So it's going to be the y value when x is 0. So when x is 0, this will become 0 because 0 squared, which is 0, times 2 will be 0. And negative 4 times 0 will be 0. So it's just going to be this. So the y-intercept, that being the y value when x is 0, is 5. Then I ask for a reflected point, which I'll show you when we get to the graph, which is the next step. So we're going to graph the function. And I'd like to graph it. I think I can do a proper graph now. Or maybe I'll make it a little bit nicer here. Could have given you a graph, a y-axis, say, and an x-axis. All right, here we are. The vertex is at 1, 3. So let's go and mark that in. Let's say this is 1 right here. 1, and then 1, 2, 3. So the vertex will be right here. And now we have to look at the parabola and say, does it open up or down? And the A will reveal that story. The A is 2, which is positive, so it opens up. Okay, open up. But we need something else. We've got this point here, 0, 5, which is the y-intercept, and that's the y value when x is 0. X is 0 on here, y is 5. So here I come, 1, 2, 3, 4, 5. So this right here would be the y-intercept right here. That's a point on the parabola. Axis of symmetry, I forgot to put this in. That's the first thing we found. That was this. This is x equals 1. So half of the parabola is to the left of it, and the other matching half is to the right of it. Okay, so 1/2 looks something like this. Right through, going right through the y-intercept, like that. Do you remember that business about the matching point? The matching point will be the one that matches this y-intercept point. So it's going to be as far to the right of the axis of symmetry as the y-intercept is to the left. So the y-intercept is 1 unit this way, so the matching point will be 1 unit this way. So if I come here and I count 1 unit here, approximately, and I come up, this one will be the reflected point. I think I said matching point. This is going to be the reflected point. And you can get it. It's at 1, 2, and then 1, 2, 3, 4, 5. 2, 5. So the rest of the parabola will look like this. And this right here is the reflected point, which is 2, 5. And the reflective point just helps you to graph it on this side to match the graph on that side. All right, so this is one you will do. I will tell you this much: your A and your B and your C. The A would be what? -1. The B will be -8. And the C would be yours. I'm sure you can get that. C is okay. So you can do that one. Now, while I'm on this page, find the zeros. I should say here of, to make sense, each quadratic function by factoring. Okay? And by factoring, we want to find two binomials, which when you multiply them together, you get back this quadratic equation. So what would these be? We're looking two numbers which when you add them together, when you multiply them together, you get 2. When you add them, you get negative 3. So you could say, well, positive 2 and a positive 1 would give me a positive 2, which would be right. But when you add these together, would you get negative 3? No. So these would not work all the way through. How about negative 2 and a negative 1? Negative 2 times negative 1 would give you a positive 2. And when you add these together, you get a negative 3. So those would work. The factors then would be x minus 2 and x minus 1. Okay? And you're looking for 0, so you're looking for x values here that would make y, which is f of x, 0. So you got two options here. I'm going to take it over here. X minus 2 would have to be 0 because it would be a 0 times something to give you a 0. And for this to be true, you add 2 to both sides, and you get x would have to be equal to 2. So that would be one answer. And the other one you'll get from this x minus 1 would have to be 0, because again 0, it would take 0 times something else to give you 0. So here's the other option, x minus 1 to be 0. We add 1 to both sides. That's 1 is gone, so x would have to be equal to 1. So those would be your two. And I'd like you to go ahead and do this one and this one. All right? Do them similarly. All right, let's take a look at something else. Okay, did we do these? Yes, I think we did. Absolute value. Let's go to the back page, which would be the adding and subtracting with complex numbers. When we add these, we simply add the real parts together. Here's one complex number, here's another. So we'd add the real parts together. And when we put those real parts together, that would be a 7 and a minus 5 like that. And the complex parts together would be a negative 6i along with a minus 2i. Both will go together. So 7 minus 5 would give me 2 for the real part. And negative 6i minus 7i would give me, negative 6i minus 2i would give me a minus 8i. That would be the result. You should do this one yourself if you have not already done so, and let's do a subtraction. Subtraction is a little bit more challenging, but not hard. So for the subtraction, we got the 3 plus 7i. So here it is, the 3 plus 7i. Understood. We have a 1 outside here. Outside is not a 1, it's a negative 1. So we're going to do the distributive property like this. Positive 1 times positive 3 gives you a positive 3. Positive 1 times positive 7i gives you a positive 7i. In this case, negative 1 times negative 10 gives you a positive 10. And finally, negative 1 times positive 4i gives you a negative 4i. Okay? So now, again, we put the real parts together, which would be the 3 and the 10. Positive 3 plus 10 is a positive 13. And the imaginary parts, 7 minus 4i would give you a positive 3i. Okay, so that would take care of that one. And then you do the multiplication by doing 3 times everything in here. So it would be 3 times 4, which would be 12. And then 3 times 6i, which would be 18i. And then you do multiply everything by negative 5i. Now negative 5i times 4 would be negative 20i. And negative 5i times positive 6i would be negative 30i. I squared.